Here's my new prototype second generation frequency counter. It's a little bit simpler than the first one. Here we have a 74HC595. This is an 8-bit counter, but I'm tapping it on the 4th division. So let's see, it's divided by 1, divided by 2, divided by 4, so divide by 8. Right now it's configured to take whatever input frequency we have and divide it by 8. And that's required because it's going directly into the hardware input pin of the ATmega48. And unlike some of the PIC microcontrollers, this hardware counter is synchronous with the clock. So the input frequency has to be at least or less than half of the clock frequency. Now I'm clocking this with a 12 megahertz crystal. I initially tried the 8 megahertz internal RC oscillator, but it was very, very unstable. So for counting, you need to use a crystal. So I'm trying to get it below 6 megahertz. And I'm testing it with an input signal of 7 megahertz. I could have just divided it by 2 and it would be fine, but I went ahead and divided it by 8 so I can use higher frequencies. From there, it reads the frequency 10 times a second, and it shows it on the screen. This is a small transmitter I built a while ago. It's made to cover all of 40 meters, the 7 megahertz. So between 7.00 and 7.3 pretty much is what it can create. And as I twist the knob, you can see I can tune all the way around. And then as I go up past 7, up to about, not quite 7.3, but you get the idea. So I'm going to take it around halfway through the 40 meter band, which is about 7.17, and I'm going to swing over here and take a look at the radio. I have the radio here set to listen to 7.123 megahertz. So if I output that frequency here, we should be able to hear it on the radio behind me. 7.123. There we go. You can hear the tone. You can hear the tone pretty clearly. So that demonstrates this oscillator transmitter works, frequency counter works, and of course you can hear it on the radio. I'll change the frequency. Notice that instead of having a full character display where it goes all the way to the single hertz, this is the only useful amount for amateur radio, and at least for my purposes. So I'm leaving it as simple as I can and just showing 4 decimal places. Also, that allows me to update the frequency very quickly. If I wanted to show all the way to the single hertz with a counter mechanism, I would have to update the display only 1 time per second. This way I can update it 10 times a second, and it's very, very smooth. So that's the general idea of what I'm working on, and hopefully I can have a very simple, inexpensive frequency counter to go on a box like this, and then I can have an all-in-one transmitter really inexpensively in a small enclosure. So that's what I'm currently working on.